Okay, let's look at a review of enthalpy. This unit is long, and if we break it into two parts, it's a little easier to digest. Enthalpy is the exchange of energy. Okay, it's the change in thermal energy. And so in our everyday life, we see that as being cellular respiration and photosynthesis. That's in our everyday life. It happens all the time. Anytime we have a breaking of bonds or a forming of bonds, we have a release or an absorption of energy. And so what we can say is that the thermal energy is equal to our change in energy. And so this is thermal or kinetic. It's our energy in motion. And this is our potential energy, or the energy of the system. And so things that we need to remember for just looking at the Q side of things is we learned this formula. Q is equal to mc delta T. Q must be in joules. We don't have any choice. You need to know the meaning of specific capacity. And that what it means is that it's the amount of energy it takes to raise 1 gram of substance 1 degree Celsius. We use Q is equal to mc delta T when there's a transfer. A transfer of heat. So anytime that there's a transfer of heat, we're going to see a change in temperature. And the other thing that you need to know is you need to know the difference between calorimetry questions the styrofoam cup versus with a metal calorimetry. So this particular one is looking at Q total being equal to Q water plus Q of the metal. When we look at the chemical system, the potential energy, there's a couple different ways that we can talk about it. We can talk about it in terms of potential energy diagrams. And so we learned two of them, where this is the potential energy and this is the rate of reaction. And we can see that we have energy for the reactants. The potential energy is very high, whereas the potential energy for products is very low. The difference between the two is going to be a negative delta H. Or if we see reactants with a low potential energy versus a high potential energy for the products, the delta H is going to be positive. And so if we have a negative delta H, this is going to be exothermic, right? The high potential energy, these bonds are ready to be formed, Whereas in here, where we have the reactions are very low in potential energy, they're quite happy being that way. They don't want to change. They don't want to break their bonds. And this is endothermic. And we look at this as a step down. So from reactants down to products, or we look at this as the step up, where we go from reactants up to products. That's one way to communicate potential energy. Another way is through the delta H notation, or molar enthalpies. Okay? So again, same terminology, exothermic. We're going to have a negative delta H, whereas for endothermic, we're going to have a positive delta H. Delta H can be determined by using the number of moles of the reactant, multiplying it by the delta RH, the energy of the reaction. And when we're talking about calorimetry, we can look at, or not calorimetry, but when we're looking at a reaction, we can look at specific amount versus the balanced reaction. And so we have moles and we have delta H. And over here, we also have moles of the entire equation. This is where you would have 1 glucose plus oxygen is going to give you 6 carbon dioxides and 6 waters. And so you would use the moles from there. This would be looking specifically at the number of moles of 1 glucose. And the language between these two that talk is the delta RH, the energy of the reaction. And then we learned some equations that also tell us if it's exothermic or endothermic. And we call those thermochemical equations. And so delta H is specific. And only applies to the moles in the balanced reaction. And what does that look like? It looks like this. A little a will represent the number of moles of the first reactant versus the number of moles of the second reactant, plus, let's say, 79 kilojoules will give us the number of moles of a first product and the number of moles of our second product. And this particular format is a double replacement. Because our energy is written on our reactant side, we know that this is endothermic. And if we were to have it like this, we would say that because the energy is on the product side, it was released, it's exothermic. So here, once we're done this summary, I have a huge, big challenge for you. Here's my challenge for you. Spring break homework. So 4 marks. I would like for you to do, actually, let's do this. For practice, I would like for you to do a few review questions. For marks, so for practice, I want you to do this sheet. For marks, there's quite a few of these sheets. There's 1, 2, 3. There's 8 questions. For practice, for marks, I want you to do enthalpy chapter test